Hey, good morning, everyone. Welcome to Electrostatics. For the next couple of classes, we're going to learn about the three different ways in which an object can become electrically charged in the first place. So last class, you just dealt with the nature of what charge is and what static electricity is. Now for the next two classes, we'll talk about how objects become charged in the first place. So the first one that we're going to learn about, which is what we're doing today, is charging through friction. And it's exactly what it sounds like. Literally means that when two objects rub together, one object will probably rip electrons off of the other object. So as you go through the lesson, you'll notice part A has a little bit of an online simulation for you to click on. We'll have a few of these in here through PhET or the physics classroom. Just click on the link. It's really easy. You just hover your mouse over the balloon, and when you click and drag, you can move the balloon wherever you see fit. And so obviously the goal of this is to see what happens if we take a balloon and rub it on this lovely sweater here. And of course, watch the charge that happens. And so as we rub that balloon on the sweater, you can see that because of the act of friction, the balloon is essentially ripping and taking electrons off of the sweater. And so the balloon ends up with a negative charge. The sweater ends up with a positive charge because it has lost the electrons. Again, you'll notice if I move the balloon back to the middle and I let it go, what does it do? It goes flying back towards the sweater because we know that since the balloon's negative and the sweater's positive, opposite charges attract. So the balloon is now attracted to the sweater. We'll return to this simple little simulation later on in the week to show some induction. So what I have in front of me are two common types of devices used in physics to help measure or detect the presence of electric charge. So both of these objects are referred to as electroscopes. The one right in front of the camera is literally just a tiny little styrofoam ball that's been painted a darker color so you can see it easier in the camera, and that's known as a pith ball, P-I-T-H, so a pith ball electroscope. The one in the background in the little plastic casing there has a little foil leaf, little metal leaf down at the bottom. You might have seen them in last class's video, and it's called a foil leaf or a metal leaf electroscope. Again, these devices are just here to show the presence, if any, of an electric charge. So what I have here is just a standard plastic rod. And this plastic rod has just been sitting here on the kitchen table. It shouldn't carry any charge, and that's what we should expect. In fact, you might even remember this simple little activity way back from September. If I bring the rod as close as possible to the pith ball, we appear to see that nothing happens, which is what we would expect. I would assume that both objects are electrically neutral. You bring them close, nothing happens. Again, bring it close to the metal leaf electroscope. You always deal with the top metal sphere there. Absolutely nothing happens. And that's not surprising, that's what we expected. Now, what I also have is a piece of animal fur. And so we're going to use the animal fur and rub it on the plastic rod. And so the act of doing this is no different than what we did with the balloon and the sweater. Okay, it's just now it's not a computer simulation. The act of rubbing the fur on the plastic rod is actually ripping electrons off of the fur. So the plastic rod picks up a negative charge, and the fur is left with a positive charge. And so now we should see that if we bring the rod close to the pith ball, we should see an evidence of that now. Okay, and again, if you watch carefully, you'll notice that I didn't touch the rod or the pith ball at all. You bring the rod close, stop it from swinging again, and we see that the ball is attracted now. It's physically moving towards the rod. So that's evidence compared to 2 minutes ago that the rod has now picked up an electric charge. Clearly there is some sort of force of attraction being exerted on the pith ball. And we'll bring back this pith ball later in the week, but we will notice something interesting that after I allow it to actually touch the rod, okay, after it touches, now we actually see that the pith ball is repelled by it. So, and again, you learned from yesterday that if it's repelling, the only logical conclusion is that they are oppositely charged. So that's what you're dealing with today. We're dealing with charging by friction. The only question that might remain is, how do you know which material picks up which charge? And that's through something known as the electrostatic series. There's lots of different versions of this. It's sometimes called the triboelectric series. I could have a electrostatic series that has 100 different materials on it. Here's just one sample of many. Generally speaking, it's put in order of what we call a weak hold on electrons at the top and a strong hold on electrons at the bottom, or sometimes referred to as electron affinity. And the idea is that the stronger the hold that a material has on its electrons, the more likely it is to rip electrons off of material with a weaker hold. And so if I take a rubber rod, here I can find rubber down here has a fairly high electron affinity, and rub it with cat's fur has a weaker hold on electrons, we can conclude that the rubber will rip electrons off the cat's fur, making the rubber negative and the cat's fur positive because it's lost electrons. If I were to take the cat's fur and rub it on acetate, which is a type of plastic, it's actually the reverse now. We see that cat's fur is lower down, has a stronger hold on its electrons compared to acetate. So the cat's fur would rip electrons off of the acetate. So it's always important that if you're answering questions involving friction and what material develops what charge, that you have some sort of access to an electrostatic series. And then you'll answer some of those questions here in the friction practice questions.